Okay, this is our video for chapter 18, sections 1 through 3, and we're dealing with some ideas about batteries and current and voltage and resistance. So, here's some example problems that go with our notes. And number 1 says a steady current of 2.5 amps. Again, those are amps. That's how we measure current. And an amp is a coulomb per second in a wire for 4 minutes. Question A says how much total charge passes by a given point in the circuit during those 4 minutes. And question B says how many electrons would this be? So let's start with our givens. Okay, our givens are our current is 2.5 amps, which is 2.5 coulombs per second. Okay? And our time, or change in time, is 4.0 minutes. Okay? So that's what we're given. Now, what do we want? Well, we want, for part A, we want how much charge goes by, so that's change in charge, and that'll be measured in coulombs. And for part B, we want the number of electrons, so we want the number of electrons that pass by. Okay, so let's see what we can do to find that. So I'm going to write my U's. And my U's, my first equation is current, I, is equal to change in charge over change in time. Okay, so that means since I want to find charge, change in charge would be the current, I, times the change in time. So I get 2.5 amps times 4 minutes, which is 2.5 coulombs per second times 4 minutes over 1 times 60 seconds in 1 minute. And you can see my minutes will cancel and my seconds will cancel, and I'll get, once I type in a calculator, 600 coulombs. So that's my answer for part A. Now for part B, I want to know the number of electrons. Well, I start off with my change in charge was 600 coulombs, and I know that in 1 electron there's 1.6 times 10 to the negative 19th coulombs. My coulombs will cancel, and when I type that in the calculator, I get 3.7 times 10 to the 21st electrons. Alright, so again, the big equation here was current equals change in charge over change in time. And in the problems you're going to see you do that a bit. Okay, now let's look at a second problem. Okay, number 2. Small flashlight bulb draws 300 milliamps from a 1.5 volt battery. So I'm going to start with my givens. And let's see, my current is 300 times 10 to the negative 3 amps, which is 0.3 amps. Again, milli is 1,000th. And my voltage is 1.5 volts. Okay, remember that's potential difference also. Okay, Now, what do I want? For part A, I want to know what is the resistance of the bulb, which we designate by R, which is measured in ohms. The Greek symbol omega stands for ohms. If you look at any electronic device you have, you'll probably see that symbol on it. And for part B, we want to know the current, which is measured in amps, if we change the voltage to 1.2 volts. So if we drop the voltage by a little bit. And so we're going to use probably one of the biggest formulas there are in electronics, and it's known as Ohm's law, which is V equals IR, where V is in volts, I is the current, which is in amps, and R is the resistance, which is in ohms. And you need to know that an ohm is 1 volt per amp. Okay? So Ohm's law is huge. We're going to use it this chapter, the next chapter, and the chapter after that. Okay, so I'm going to start with V equals IR for part A. And I want to find R, so I'm going to do V divided by I. So R is 1.5 volts divided by 0.3 amps. And a volt per amp is an ohm, so I get, when I type that in the calculator, I get 5 ohms. Okay? And then I want to find I, so I'm going to use V equals IR again. And I'm going to say that I is V divided by R. So in this example, I is going to equal 1.2 volts, which is my new voltage, divided by 5 ohms. Remember, an ohm is a volt per amp, so the volts will cancel and the amps will be on top. And I get 0.24 amps. And that's how you deal with current and resistance and voltage.